In this video, our task will be to solve the following quadratic equations using the square root property. And just a reminder about the square root property. So what that says is that if we have x squared equal to k, then x can be positive or negative in there, right? Because when we square it, it's positive. So when we take the square root of both sides of that, we're going to get x equal to plus or minus the square root of k. Okay, so with that in mind, let's try these examples. So if we have 2x squared equal to 10, the first thing I want to do is get x squared by itself, right? So I'm going to divide both sides by 2. So that leaves x squared equal to 5. And then I have to take the square root of both sides, which leaves x equal to plus or minus the square root of 5. Okay, so the solution set is negative square root 5 or positive square root 5. Okay, so in this next example, we have x minus 2 quantity squared equal to 16. So since we have something squared equal to a number, I can take the square root of both sides, which would leave x minus 2 equal to plus or minus the square root of 16. And of course, the square root of 16 is 4, right? So I have x minus 2 equal to plus or minus 4. And then to solve that for x, I need to add 2 to both sides, so I have x minus 2 plus 2 equal to 2 plus or minus 4. So x is equal to 2 plus or minus 4. Okay, so what does that come out to be? I have x equal to 2 plus 4, which is equal to 6, right? Or x equal to 2 minus 4, which is equal to negative 2. Okay, so the solution set then is negative 2 and 6. Right. And of course, I would also encourage you to, in any of these examples, you can plug the solutions back into the original equation, see if you get a true statement. Okay, so now we have t squared plus 6t plus 9 equal to 0. Okay, so in this example of t squared plus 6t plus 9 equal to 0, I notice that t squared plus 6t plus 9 is a perfect square trinomial. If you don't notice that, you can just factor it, right? So you ask yourself factors of 9 that add to 6, well, 3 and 3, right? So you'd have t plus 3 times t plus 3 equal to 0, or t plus 3 squared equal to 0, right? That's where we were really headed there. Now, when you take the square root of both sides, the square root of 0 is 0, right? So we end up with t plus 3 equal to 0. And of course, we have to subtract 3 from both sides. So t is equal to negative 3. So the solution set would be negative 3. So in this example of 4r squared minus 20r, oops, let's fix that, minus 20r plus 25 equal to 7. So 4r squared minus 20r plus 25 is a perfect square trinomial, I believe. So I notice that 4r squared is a perfect square, right? The square root of that is 2r, and the square root of 25 is 5, and we have a minus 20r in the middle. So I'm willing to bet here if we have 2r minus 5 times 2r minus 5, let's see, do a little foiling in your head. So if we've got 2r times negative 5 minus 5 times 2r, so that's negative 10 minus 10, which is negative 20. So that works. So we would have 2r minus 5 quantity squared equal to 7, and then we can employ the square root property as we're supposed to, right? So if you take the square root of both sides, we're going to have 2r minus 5 equal to plus or minus the square root of 7. And if we add 5 to both sides, 2r minus 5 plus 5 equal to 5 plus or minus the square root of 7. Okay, so now we've got 2r equal to 5 plus or minus the square root of 7, and I need to divide both sides by 2. So r is equal to 5 plus or minus the square root of 7 all over 2. Out of room. All right, so the solution set then would be 5 minus square root 7 over 2 and 5 plus square root 7. Okay, so we notice in the first two examples on the top of this slide, we already had something squared, right? Or something that we could easily see that we could get something squared on one side and then take the square root of both sides. In the case of the last two examples, we had to do a little factoring first, right? So that we would have something squared, a binomial squared, that we could then take the square root of both sides. And so it's not quite as simple until you do that factoring. So using the square root property works well in cases like this where you have perfect square trinomials already.